All right, so what I want you to do is expand these. Now, when you have a binomial squared, what's the first step? How? What do I have to do first? Perfect. So x plus 1 times x plus 1. So we need to write it out multiplied by itself. And then what are you going to do? FOIL. Okay, so can you please do that for each one of these? Each one of these, I'd like you to FOIL them. X, then you have x times 1, x times 1, and 1 times 1, right? And the last is you collect the like terms in the middle. Squared. All right. So remember foiling? It's good times in grade 10. These are all perfect squares, right? Because they're x plus 1 squared, so it's a perfect square. And so notice that with a perfect square, the middle terms are always the same, right? So it's like the if you notice that this, if we look at this number here in a perfect square, and you look at this number here, okay? That's what I want you to look at. So notice the 1 compared to the 2, the negative 2 compared to negative 4, and the 3 compared to positive 6. What do you notice? What's the pattern here? It's multiplied by 2. It's double. And that makes sense because the middle terms are the same thing. So if you're adding two things together that are going to be the same, it's just going to be the same thing as 2 times that number, right? 3 plus 3 is the same thing as 2 times 3. 6 plus 6 is the same thing as 2 times 6, right? So they're doubled. That's really important. And then what do you notice about, instead, let's look at those numbers there. The 1, 2, and 3. Positive 1, negative 2, positive 3, 1, 4, and 9. Positive 1, 4, 9. They're squared, right? It's a perfect square. So 1 squared, 1. Negative 2 squared, positive 4. 3 squared, 9. So we're going to be using these patterns to our advantage today. So what are we doing? Well, what we want to do today, very, very important, is we want to change standard form into vertex form. So we're going to go from ax squared plus bx plus c into our vertex form, which tells us our vertex, right? The only thing useful about standard form is what? What's the only thing really useful about this form here? Your y-intercept, c. That's about it. Pretty hard to graph from that. Very useful to have our vertex, right? Know the middle of the graph, the maximum, axis of symmetry. And then if we know the a value, we know the shape, and we can kind of get points from there. It's a lot easier. Okay, so if this initially was a perfect square, it had to have been x plus what squared? Any guesses? 3. Remember, the middle term was doubled. So if it was x plus 3 or x plus 3 plus times x plus 3, what would the last term had to have been? 9. 9. Okay, so notice there's actually an easier way to get that. Let's try one more time. This would have had to have been x what? Minus 4 squared. And so the last term will have to be 16. What are we doing? So you're taking the 6 and the negative 8, and what did you do to make this number? You divided it by 2. And then what did you do to make, once you got that number, how did you make this guy? You squared it. You divided it by 2, and then you squared it, right? So negative 8 divided by 2 gave you the negative 4. When you squared it, did it give you 16? Yeah. I'm going to remove some of these arrows. Oops, I don't want to remove that one. Okay, so let's do that same thing here. 14, let's divide it by 2, which gives you what? 7. So this had to have been x plus 7 squared. And so to get the last term, we now square that. 7 squared is 49. 3 squared, which is 9. So what we're going to want to do this unit is turn things into perfect squares, because that vertex form has a perfect square in it, right? Do you see the perfect square? We're going to want to make a perfect square, the x minus p squared, or x plus p squared, whatever it is, right? We want to make that. So we're going to have to use that property to make it today. So we're specifically looking at today when a is 1. Monday would be when a is not 1. Okay? So when a is 1, here's like a worked out problem for you. So just let's read through the steps, and then we're going to do it ourselves. So if you ever forget how to complete the square, it's all here. So what we want to do is starting by separating the first term and the second term. Because the first term and the second term is what we want to turn into the perfect square. That's what we want to turn into a perfect square. Okay? So it's essentially what we want to do is we want to take it and figure out what do we have to add, what constant do I have to add to make that a perfect square. So what did we just do? 16, right? Divided by 2 and squared. So that's what we're going to do. We're going to take that middle term, divide it by 2, so it has to be x minus 4 times x minus 4. So minus 4 squared is 16. Okay? So but the thing is, can you just magically add 16 into anything? No, and keep the same equation. No. So if we add 16, we're going to have to subtract 16. So that this equation is still the same thing as what we started with. Okay? And that's okay. We're going to then move the negative 16 out of the brackets. Okay, we're going to take it out because we don't want that. We just want the plus 16. We want this, which is a perfect square. And so the negative 16 plus 7 will collect like terms, make it minus 9. So that's going to turn into your q value. And then last is we're going to factor this, which is really easy, right? It's going to be the square root of that number or half of that number. So it becomes x minus 4 squared. X minus 4 times x minus 4. And now it's in vertex form. There's my p value, there's my q value. Okay, that's our goal today. So looking at this would have a vertex of what? Positive or negative 4? Positive 4, and so you guys know, you just don't want to say anything. Parabola would open in this case up. A value is just positive 1. And the minimum would be at, which one would be the minimum value in the vertex? The y or the x? The y. So the minimum value is always the y coordinate of the vertex, and the axis of symmetry is the x value of the vertex. So x equals 4. Okay? All right, let's try these. That's all we have today. Right here. Okay? So, first step is we're going to separate. I'm going to try and go step by step really slowly at this point. We're going to separate the first term and the second term. The x squared and the x from the constant. Because that constant is at the perfect square? No. That's not the number we want. Okay, so what is the number we want? So we want to turn this into a perfect square inside here. So how do I get that? Nadir, what's so funny? What? Okay, what would I do?
I don't know.
You don't know? Yeah? 9. So remember, if it's x, if we had x squared, x squared plus 6x plus something, right? You want, it's going to turn into x plus what plus times x plus what? 3, right? It's half of it. And so to then get that number, we then square it. So divide it by 2 and then square it. So what we did here is 6 divided by 2 and then squared. So we're going to add in, you said it, 9. Can we magically add 9? No, so we're going to subtract 9. Okay, we're leaving it inside the brackets for now because when our a value is not 1, it's going to change a little bit. So we want to leave it inside. So our next step is now to pull out the negative 9. See, if there was an a value in front, I would have to multiply negative 9 by that a value to bring it out. And that's what we're going to do tomorrow. Okay? But, yeah, Monday. Sorry. Tomorrow is PD day. Monday. That's what we're going to do Monday. So in this case, there is no a value. So can we just bring the negative 9 outside? Sure thing. Because you're just multiplying it by positive 1. So let's leave the plus 9 inside and bring the minus 9 outside the brackets. All right. Okay. So now, we can kind of do two things at once. We can factor this first guy. So what did he factor to? X plus 3 squared, right? And the easiest way to get that is just take your middle term and divide it by 2. Because it also will be the same sign as the middle term. So just your middle term divide by 2. So when you divide this by 2, you're going to get that number. Okay, and then last, negative 9 plus 8, negative 1. So let's state our vertex. What's our vertex? Negative 3 and negative 1. Okay, do you want to try one? Or do you want to do this one together? One more together. And then you try, okay? So first step, we're going to separate. And you can kind of, if you want, we're separating the first two terms. You can leave that space there right now. We can go ahead, kind of combine the first step and the second step at the same time. So separate the first two terms. We want to turn this into a perfect square, right? Oops, it's a minus 12. So we want to figure out, okay, what would we have to make that a perfect square? Well, what is it going to become in factored form? It's going to become x minus 6 squared, right? So what is that number that we're going to have to add and subtract? 36. So we take negative 12, divide it by 2, and then square it. So negative 12 divided by 2 is 6. 6 squared is 36. Add 36, and we subtract 36. Next step. Okay, move which one outside? The minus, or always the minus, because when you have a perfect square, right? If this is a negative, negative 6 times negative 6, the perfect square, this is always going to be a positive value. It doesn't matter if that's negative or positive, because negative 6 times negative 6 or positive 6 times positive 6 both give positive 36. So let's move the negative 36 outside. Okay. Okay. We can kind of do two things at once here. Let's write this guy in factored form. So what does he become in factored form? X minus 6. So just that middle term divide by 2. X minus 6 times x minus 6 is what we have over here, right? Kind of wrote on the side. Negative 36 plus 13. Negative 23. So vertex 6 and negative 23. I'd like you to try, oh shoot. We're gonna do this one together. I wanted you to try that one, I forgot why. That's okay. It's really nice when it's beautiful numbers like that. And by beautiful numbers, I mean integers. It's not always gonna be. Everyone's favorite thing, fractions. Yay! Okay. Y equals, first step is separate the first two, right? So let's separate them. X squared plus 3x. Do you want to leave a space right now? Or do next line? Right now. Okay, let's leave the space right now. Separate the first two, and leave a space. How do I figure out what to add and subtract? Take the 3, divide it by 2, and then square it. Okay. What happens when you square 3 over 2? What does it become as a fraction? No. 9 over 4. Just square the 3 and square the 2. So 9 over 4. Just square both those numbers. We are going to add 9 over 4 and subtract 9 over 4. If you use your calculator, yes, it can do this for you. Okay, 3 divided by 2 squared, and then you go math, enter, enter, 9 over 4. Next step, take out the minus 9 over 4. Good. So we're going to move that outside. And then we need to add those together. We need to add negative 9 over 4 plus 5, right? We have to combine those and factor the first part. Okay, so in your calculator, math, enter, enter, what does that become? You should get 11 over 4 because it's a negative 9 over 4 plus 5. Get the same thing? Or yeah. So then, what does this first part factor to? X plus what? 3 over 2. Remember, we take that middle term and divide it by 2. It's the same as the inside right there. So 3 over 2 squared minus, no, it was plus 11 over 4. So there's vertex form right there. So vertex would be negative 3 over 2 and positive 11 over 4. So I'd like you to try example 4. Making good time. Negative 41 over 4. minus 16 over 4. Yep. So check that you have the same answer. You want to make sure you practice this and you get good at it, because on Monday we're going to start with the a values not 1. Okay. Really quickly, if there's no constant, so if you had something like x squared plus just 5x, okay, it becomes really easy. So don't fret. We're still separating these first two. There's just nothing added over here, right? And then you would divide both sides, divide this by 2 and square it still. So 5 over 2 squared is 25 over 4 minus 25 over 4. And then you just bring this out. It's the same idea. But don't forget, students often forget to write this little square. That's not a highlighter. This little square. Don't forget that, okay? To write that when you write it in factor forms, remembering that little square. Okay? So today's homework is, what is it? Page, I'll just finish this one quick. That's not a pen. That's still not a pen. 5x plus 25 over 4, so this just moves outside. And then this would become x plus 5 over 2 squared minus 25 over 4. So there's no constant. You still separate those first two together. Okay? If there was no x, like something like this is already in vertex form. If there's no x value, that is vertex form and standard form at the same time. Okay? So something like that, it's x minus 0 squared, right? If you compare it to this formula, it's the same thing as x minus 0 squared plus 3. Would you agree? Because that's still the same thing. So that is vertex form and standard form at the same time. So when there is no x, it's just x squared and a constant, it's kind of in both forms at the same time. That is your y-intercept, which happens to also be your vertex, the y value of your vertex. Okay, when there's no horizontal shift, that's why there's no horizontal shift. Yeah? Yes, negative 41. Thank you. Absolutely. Okay, so assignment, we have lots of time, and I will hand back your textbook for a little bit. Would be page, here it is, page 192, numbers 1, 2, 6A, 7A, 8A, and 12A. It's not that much. Okay, you want to get your textbooks open, and then if somebody can remind me, the class is over at 11:53. Sorry, yeah, 11:53. So at 11:40, hand back your tests. Okay? We'll pack up, and then I can go over any questions that come up. Okay? So 11:40. Oh, that's not. It's 10 minutes. Maybe 11:43. All right. Sure.